Thermoboys Productions.
Today we will be describing the second law of thermodynamics. As we saw in the first law, it allows processes that we do not experience in nature, so the first law is symmetric. However, there is a need for a second law that will restrict the direction of different processes. So the second law is telling us what is possible and what is not. So we have two main statements. We have the Kelvin-Planck and we have the Clausius statement.
"2,000 years later."
Normally, heat transfers from high to low. So if we have a reservoir with T high and a pump, leads to a T low. This is for every cycle. If we want to return from T low to T high, there needs to be work. So normally we'll have a high temperature, let's say 100 degrees Celsius, and we'll flow to a lower temperature of 50 degrees Celsius. But what if the roles were reversed and we want to go from 50 degrees Celsius to 100 degrees Celsius? Well, this is where the Clausius statement comes in. Clausius statement says that we have a T high, we have a pump, and the T low. Here we have the Q out, which is the heat out. And here we have the Q in, heat in. But we need work, and we need work in.
So the second major component of the second law of thermodynamics is going to be the Kelvin-Planck statement. Kelvin-Planck statement states that if you go from a heat source to provide work, some of that heat needs to be rejected. We can see this in a heat engine where there's a reservoir of T high going into a cycle to provide work. A certain amount of this heat has to get rejected to a T low. We cannot transfer 100% of the heat we give in into net work. We can also calculate the efficiency of this cycle by calculating what we get over what we put into the system. Which in this case is going to be, we are getting a workout and we're putting in a Q in. So that's going to be efficiency is equal to workout over Q in. And we also know that workout is our high temperature minus our low temperature. So we can derive that into QH minus QL over QH, which then simplifies into 1 over QL minus QH.
And we need work in, more specifically. Why?